Alright, continuing talking about arithmetic and geometric sequences. So if you add the same amount each time, that could be positive or negative, it's arithmetic. So if you add 2, add 2, add 2, add 2, or 3, 4. Or in this case, we're subtracting 2 every single time. That makes our common difference negative 2. So it's arithmetic because we're adding and subtracting the same amount each time. And there's a negative 2n in here. So what we always practice is that if it's negative 2n, I want to subtract 2 the first time from 12 if we go backwards. And that's how we get our nth term equation. So 12 is kind of like our 0 term, and then this is our slope, m, or if you just want to think, our d, our common difference, times n. In this one, 3's are staying the same, but the top is being multiplied by 2 every single time. I found the nth term equation, and then it's asked to find the 12th term, and so we can plug in negative 2 times 12 plus 12. So the 12th term is negative 24 plus 12, which is negative 12. You can always plug in, just double check your nth term equation, plug in 1, plug in 2, plug in 3, plug in 4, plug in 5 to see if you get those terms. So our r equals 2, and this is a geometric sequence because we're multiplying the same thing each time. So, kind of like we did on an earlier problem, we're going to use our 1/3 as our starting spot, and we're going to multiply by 2 each time. When we repeatedly multiply by 2, we get exponents. And then we don't want to multiply by 2 the first time because we want to get 1/3. So I'm going to subtract 1 the first time so that this 2 is not multiplied. And there's our nth term equation. And to find the 12th term, we can plug 1/3 times 2, 12 minus 1. And we get 2,048 thirds. Alright, so the next one, fractions, right? And so if you can get it into common denominators, this 3, if we were to put it over 3, is the same thing as 9/3. And the 5, if we were to put it over 3, is the same thing as 3 over 3, so 15 thirds, because 15 divided by 3 is still 5. So 9, 11, 13, 15, 17, we are adding 2 thirds every single time. So this is an arithmetic sequence, because we're adding the same thing each time. So we're going to fashion this after this other one over here, where we had our 2/3 times whatever n is, and then we're going to make sure we start off in the right spot where our 0 term is 7/3 if we subtract 2/3 one last time. So that's 7/3. A sub 12, 2/3 times 12 plus 7/3. Is 31 thirds. Alright, keeping going. We've got 1, 4, 9, 16. So here you added 3, then you added 5, then you added 7. So it's not adding the same thing. 4 over 1, 9 over 4, 16 over 9. It's not arithmetic or geometric because we're not adding the same thing, we're not multiplying the same thing. So it's neither. You can find an nth term because you notice 1, 4, 9, 16 is n squared. Now, we don't technically have to do this because in the directions it said only find the nth term, but it was doable. We could do it, so I'm doing it. A sub 12, the 12th term, is 12 squared, which is 144. So that's the 12th term. M, 4, 10, 16, 22, we're adding 6, adding 6, adding 6, and so that is our D. And so this is an arithmetic because we are adding the same thing each time. So we get, for our nth term, there's a 6D, 6n in there, every time we add 6. But if we multiply 6 by 1 to get our first term, we're at 6, and so we need to subtract 2, which is the term in front of it, negative 2, in order to get our 0 term. And our 12th term, a sub 12, always just want to double check, is 70. And where that's coming from is 6 times 12 minus 2. 1, 3 halves, 9 fourths, 27 eighths. So 3 halves divided by 1 and 9 fourths divided by 3 halves. If you notice that this is times 3 and this is times 2, this is times 3, this is times 2, and so our R is 3 halves. You can also notice that if you divide these, you get 3 halves. And so this is a geometric sequence, and just like this one, we're going to write it as our first term, 1, times our ratio, 3 halves, raised to the n minus 1 power. And so that again was a sub 1 times r raised to the n minus 1. Works every time, like a charm. Plug in to find your 12th term. A sub 12 so 3 to the 12th is 531,441 over 2 to the 12th, which is 4,096. All right. On to finding the missing information in the next few problems.